Welcome. In this lesson, we're going to combine the last two lessons. And what we're going to do is we're going to find all the missing side lengths and missing angle measures of a right triangle. So if you'll notice, they give us this angle measure, they give us this side length, and we know this is the right angle. But they don't give us this side length or this side length or this angle measure. So let's find those. It's easy to find the missing angle if they give us the one angle measure and we know the right angle, because all three must add up to 180. Or even better, these two must add up to 90. So to find this measure of angle I, which is this bottom one here, the measure of angle I is just going to be 90 minus the angle we know, 24. So just grab a calculator. 90 minus 24 tells us that that angle measure is 66. Now, the sides are a little bit harder. We're going to use our trig functions. Since I know this angle here and I'm looking for one, I don't care which side I start out with. Maybe I'll start out with the adjacent side. So again, I'm going to label this as the adjacent side, and this is the hypotenuse, and this is the opposite. So then I know that the cosine of 24 degrees is equal to the adjacent side, which I don't know, that side JK, divided by the hypotenuse. And we did this in the previous two lessons. So again, cosine of 24 degrees times that by 10, and I find out that the length, this JK length here, this length here is 9 point, and it says round to the nearest tenth, 9.135 or 9.1. So I type in 9.1. Now I can find the opposite side one of two ways. I can either use Pythagoreans theorem, since I know these two sides. I'm going to erase some of this so we don't get confused. So I erased a little bit, so I know this is 9.1, this is 10. I can use Pythagoreans theorem. Or I could do another trig function. I could do the sine of 24 degrees is equal to the opposite side, which by the way is this here, the ij, divided by the hypotenuse, which is 10. So now I'm going to take the sine of 24 and times that by 10 and find out that my shortest side there is 4.1 if I round to the nearest tenth. But again, I could have done Pythagoreans theorem. Now here's a triangle where they don't give us either angle, but they do give us two side lengths. So the first thing I would probably do is find the length of UV using Pythagoreans theorem. I'm going to do 1 squared plus 2 squared, because those are my shortest side, equals my hypotenuse squared, because remember the hypotenuse is always the longest side. So I get 1 plus 4 equals c squared, or 5 equals c squared, or c equals the square root of 5. Now it says to round your answer to the nearest tenth, so I'm going to grab a calculator and do that. When I do that, I get the square root of 5 is 2.236, rounded to the nearest tenth. That length UV, which is this top one here, is going to be 2.2. So I just found this length is 2.2. Now, and I use Pythagoreans theorem. Now I'm going to use my trig functions. So let's find angle U. Okay, if I'm going to find angle U, I'm going to use the opposite side and the adjacent side. I like the two sides they give us. And what trig function uses the opposite over the adjacent? That is the tangent function. So the tangent of U is equal to 1 over 2. So now I just take the inverse tangent of 1/2, and I'll find out what angle U is. Inverse tangent of 1 divided by 2 is 26.565. So if I round the angle of measure U to the nearest tenth, it's 26.6. Now what I'm going to remember is these two angles, V and U, must add up to 90. So I'm just going to take 90 and minus off the 26.6, and I get 63.4 for that third angle, 63.4. So solving these triangles is just a matter of working through the process, either using Pythagorean's theorem or using inverse trig functions or trig functions themselves. So if you have questions on how to do this, please bring them to class. I'll let you work on these and then we will move forward.